Hi, this is Bala. Good evening. Uh, in this today's session, what we are going to discuss is we are going to generate different types of signals. There is nothing but we are going to generate a square wave, ramp wave, triangular wave, and sine wave. That is nothing but we are going to convert our digital values into an analog value, right? So, uh, like our previous session, we have to open our tape software and we have to create a project. All of the steps are same. You have to create your program name. I have created a squarewave.c. Just copy, type your program, save it, and first I have to explain what the program does, right? So from this title, we are going to say that we are going to generate a square wave. So first of all, we have to study about how the square wave will be. For that, we are going to take a sample of square wave. So a square wave will consist of an high value, low value, high value, and a low value. So it will be consecutively going on. So this is the logic behind that. So initially it should be in a low value, and after that high value or high low, anything it may be. So based upon this concept, I have divided my program into two types. One will be my low value and high value. So I have defined my low value as A and high value as B. Now we have to go to the program. See, I have started my program and I have been initialized two parameters. As I already said, I am going to have two values, that is low and high, A and B. So I have two values, that is A and B. As far as my program is concerned, I have to give some delay for the difference, that is between an high and low. That is nothing but a short delay time. So that delay is being given here. So I have initialized it here, right? And another next mode is nothing but my pin select mode. This is most important one. So for our pin select mode, what we have to do is I have defined as 0 0 0 8 0 0 0. So I have initialized my pin select one register. Now you have to again go back to your go back to my previous tutorials where I have explained what pin select one does, right? So the pin select 0 means that it will be having pins from 0.0 to 0.15, and pin select 1 will have pins from 0.16 to 0.31. What does this pin select does is, as far as our controller is concerned, right? So consider a microcontroller. So see here, a pin 0.16 not only can be used for GPA, general purpose input output. It can also can be used as an external interrupt or another MAT operation or a CAP operation, something like that, right? And the same thing you can check for 0th port. 0.1 can also used as an receiver port and also PMW port and also interrupt port. So this there are 4 kinds of operation we have to choose specifically. If I have to choose only this, then I have to configure the pin select as per that. If I have to use pin WM3, I have to configure my pin select as per that. So if you are using a pin first pin GP general purpose pins, then there is no problem at all. If you have to go any other pins, then there will be a problem. So we have to go for pin select option. Okay, so again you have to see the value that I am using my 0 0 0 0 8 0 0 0. What is this is, see here, okay, 0 0 0 0 0 8 00. That is nothing but I am giving my value starting from that. This 0 comprises my last 4 bit, then again last 4 bit, then again last 4 bit. This 8 is nothing but 1 0 0 0. So I have defined 1 0. What is this? This is my 19th pin is 1 and my 18th pin is 0. You we have to go for the pin select option. This is my pin select 0th pin and I am using my pin select 1, so you have to check your 19th and 18th pin. So as far as my 19th pin is concerned, it is 1 and 18th pin is 0. You have to see the function. My 19th pin is 1 and my 18th pin is 0, so it will be acting as an A out, analog out pin. Okay, so that I have configured my value as 000800000. You got it? Right. So after that, what you have to do is, I have selected my analog output pin, that, and also you should verify that my analog output pin, I can get my output at P0.25 or A out, both does the same thing. Okay, so after that, when my condition is at true condition, so my first pin A is nothing but low value, so 0, it is an hexadecimal value. You have to convert and you should give to the board. So it is an hexadecimal value that is given to the digital to analog converter analog control register. Okay, so this register, what it does is, it converts this hexadecimal value into an analog value. Okay, so we can see a demo value for that. So if we have to check this formula, if my value is 0, anything by 0 will be 0, 0 into anything will be 0, so my value will be 0 in this register. So my first initial value of this diagram square wave will be an 0 value. You got that? So after I am giving a particular delay, again I am giving my highest value as 399. Okay, so 399 in the sense, you have to just calculate that. So I am going to my calculator and go to your programming mode, hexadecimal value, and I am giving as 399. Its equivalent decimal value is 921. Okay, so what you have to do is, again the same formula, 921 by 1024 into my reference voltage. My reference voltage is nothing but 3.3. okay, as per my microcontroller. So go to your calculator. So 921 divided by 1024 into 3.3. so my answer is 2.968. so my maximum output I can get is 2. You can vary any voltage level, but you should not go above 3.3. so you can go for 400, 401, anything you can go, but that value should not exceed your reference voltage, that is 3.3. so for my 399, which I have been given in my program, the maximum voltage level I should get is 2.968, that is nothing but 2.97. okay, so that value is being converted by this register. So I will be getting an high value, that is nothing but this voltage level is 0 and this voltage level is 2.98. okay, just save your program, then add your program to your existing project, that is nothing but square wave. So once you have saved your program, just run your program. I think you may got no errors. Okay, go to your debugging mode. So go to your setup thing. So what you have to do is remove all the thing, and as per our program is concerned, we can configure anything, that is port 0.25 or A out. So that is nothing but it is an A out pin. So click that. Okay, close that, save it and run your program. I think you have to just in your program and zoom that to check your output. See, you are getting your output. Just stop that. Now you can see my lowest value is 0 and my highest value is 2.968, that is nothing but 2.97. If you are changing that value, for example, I am changing my value from 399 to something like 200, right? Again what I have to do is, I have to go to my calculator, program and hexadecimal value. My value is 200, so 200 decimal value is 512, right? So go to your scientific mode, 512 divided by 1024 into 3.3, that is nothing but 1.65. okay, Again go to your debugging mode, run your program, you can check your output. Just stop your program and check your output as 1.65 the maximum outlet, right? You can auto check. Yeah, this was the thing, this was the logic behind this program. Then there may be some questions like why we are using 1024. This is nothing but in an LPC2148 there are 10 analog to digital converter channels, 10-bit ADC. So what we have to do is we know the formula as 2 power n. So n is nothing but 10. So 2 power 10 is nothing but 1024. So that we have, as we have 10-bit channel, I have put 1024 here. Okay. So I think it will be quite easy with this program. In the next session we will discuss about how you are going to generate a ramp signal. Okay.